Hello guys, welcome back to the channel for another Databricks video. Today we are going to take a break from this series of tutorials we've been doing recently, and we are going to see how to stream data with Delta Live tables in Databricks. As we all know, recently we moved from traditional data warehouses to modern data lakes. Data lakes provide a lot of benefits, like supporting open data formats. They support unstructured data and semi-structured data, audio data, or video data, for example. And they also support multiple APIs from languages like SQL, R, and Python. And in general, we would say that it's cheap to store a lot of data. However, like every new technology, there are defects and limitations. Data lakes do not support ACID transactions, resulting in low data quality. They do not have good data governance, and you could say that in general the performance is not the best. Due to those limitations and constraints, we had to find a better solution, and that would be a Delta Lake. A Delta Lake combines the best of both worlds, so it takes the best features of a data warehouse and the best features of a data lake and combine those benefits together to form a complete solution. In a nutshell, a Delta Lake is an open source storage layer that sits on top of data lakes and brings reliability to data lakes by adding a transactional storage layer. It supports ACID transactions, meaning that we can have better data quality. It supports data versioning and provides rollback capabilities. And last but not least, it can handle both batch and streaming data in a unified way, which is very important in a modern data landscape. By the way, if you type Delta Lake on Google, this picture will come up. This is a lake known as Delta Lake in Wyoming. I believe everyone working with Delta Lakes should visit the original Delta Lake in Wyoming someday. I will definitely do it. So how can we build a proper Delta Lake? We can do that by using Delta Live tables. Delta Live tables are a declarative ETL framework for building reliable end-to-end data pipelines. They simplify the work of data engineers on ETL development and management. It's very easy to build, to follow the Medallion architecture to build the bronze layer, the silver layer, and the gold layer in one Delta Live table notebook. Now, if you are wondering what the difference is between a Delta table and a Delta Live table, is that a Delta table is a way to store data in tables, while a Delta Live table is a declarative framework that creates, maintains, and keeps Delta tables up to date. So essentially, it allows you to describe how the data flows between the Delta tables. One of the main advantages of using Delta Live tables is that we have pipeline visibility. We have graphs of the data pipelines, and we can detect the lineage of the data. So we can visualize the journey from the bronze layer to the silver layer to the final aggregated and cleansed tables in the gold layer. It's very important, to know your lineage of your data. And we also have statistics for every table. We have the number of records written per table, the schema and the flows, a lot of important information per table. Another great benefit of Delta Live tables is that they support capture data change, CDC, or change data feed, CDF. Now, capture data change is a feature that allows you to propagate changes in the source tables and propagate those changes to the final tables without any interruptions or without breaking any data pipeline. So let's say you have merges, updates, or deletes in your source data. You want those changes to propagate to the final tables without you doing anything, right? Without interfering with the code or anything like that. And then we have change data feed or CDF, which makes coding even simpler, and it addresses the biggest pain points around CDC, including quality control and inefficiency. Now, every data engineer who has participated in data migration projects would understand that those two features are very, very important and they make your life easier. Also, delta live tables support slowly changing dimension type 1 and type 2, meaning that we can retain the history of records, also very, very important. When it comes to ETL pipelines, a valid question is, why should we use delta live tables instead of building data pipelines with Spark and Delta Lake on Databricks? First and foremost is the ability to declare and maintain data table dependencies. Very, very important. And the second reason, which is equally important, is we can manage data quality in Delta Live tables using great expectations, meaning that we can define data quality constraints on the contents of a dataset. It guarantees that the data arriving in the tables meet data quality requirements, and we can have insights into data quality for each data pipeline update. We can use either Python decorators or SQL constraint clauses. So as you can see here on the first screenshot, we define a delta live table using Python decorators, and we can also provide constraints. And if a record does not comply with our constraint, we can drop this record or we can make the process fail. And the first screenshot is constraints using Python decorators, and the second screenshot is applying constraints using SQL. Okay guys, now without further ado, let's jump into the code and do the actual work. Here I have a Python script using delta live tables to create a bronze layer, a silver layer, and a gold layer, performing aggregations, filtering, and joins. And we are going to do that using a Raspberry Pi simulator provided by Microsoft. It is free. Here you need to provide the connection string to your IoT hub. I have already created an IoT hub on Azure here, and you can find the connection string, the built-in endpoints here, and the connection string for devices under the devices blade. Here you click here, you can see the connection string, and you paste it here. And I have also changed the fields a little bit. I have added a few more columns: wind speed, wind direction, RPM, angle, etc., because what we want to do, first of all, is to send those data into our IoT hub here, to our IoT device, and then consume this data using delta live tables, and actually create two bronze tables, one for turbine data and one for weather data, and then two silver tables, one for turbine data and one for weather data, and then join those tables on the last step to create the gold layer. Okay, so here we have the IoT configuration. First, in order to use the delta live tables, we have to import DLT, right? And from the functions, we have to get all the PySpark functions here to play around. So here we have the configuration of the IoT hub. We have the IoT hub namespace, the name, the access key, and this is configuration stuff. I have explained this all these things in a previous video using IoT hub, so please check it out. And here we provide the IoT hub options and the schema, right? We have message ID, temperature, humidity, wind speed, wind direction, RPM, and angle. So that would be the payload schema that we are going to receive from IoT hub. And here, this is how we can create a delta live table. at dlt.createTable, we provide the comment whatever you want, and this, for example, bronze turbine T, this is the table name, and here this is what is going to be stored in this bronze turbine T table. Spark.stream.format, Kafka format, we pass the options, we load the data, we cast the value column as a string, and from JSON we provide also the schema, and we get the body column. And we also add a new column called timestamp, which would be the current timestamp. And we select the columns we want for the turbine data. That would be message ID, RPM, angle, and timestamp. And then in the silver turbine table, that would be the next table, right? So the first table here is the bronze table. We get the data, we store the data as it comes, we don't perform any changes, but here we can use expectations. Remember, we can use expectations in Delta Live tables to drop a record or actually make the process fail if the data does not comply with the constraints. For example, here I have added a constraint that the average angle is not null, or the average RPM is greater than 0. As you can see, the columns here are the columns that we return, that we select inside the return statement. So those columns here. How can we get the data from the bronze table that we created up here? It's pretty easy. We use dlt.readstream, the bronze turbine T table that we created up here, and then we can cast the message ID as an integer. We can rename the columns, and then we can group by message ID, and we can provide a time window using the timestamp columns of 5 seconds. And then we can calculate the average for the RPM and the average for angle, right? And then we select the columns we want. And that would create the silver table. Then we have the bronze weather table. Again, this is the original. Here we just, on the bronze layer, we receive and store the data as it is. We don't perform any changes, any filtering or anything like that. We just store the data as it comes. And here again, we use, let me change that, we use spark.readstream.format, Kafka format. We pass the options, we load the data. Again, same thing. We add a timestamp column, and we select the data we want for the weather. That would be message ID, which is the key for both tables, and this is the key that we are going to use for the join operation later on. Then we have temperature, humidity, wind speed, wind direction, and the timestamp columns. And next we have the silver weather table. Again, here we have also constraints here. If the average temperature is not null, then drop the record, and if the average humidity is less than 0, then the process will fail. So, but here in the return statement, as you can see, we read the bronze weather table that we created up here, and we can filter the wind direction to be left, and we can group by again and calculate the averages, right, of average temperature, humidity, and average wind speed, and select the columns we want. If you don't provide a window function, you cannot aggregate streaming data. Just saying, be careful with that. And the last step would be to create a Delta Live table for the gold layer. So we create the gold T table. We read the silver turbine table and the silver weather table, and we are going to join those tables. As you can see, we join silver table 1 and silver table 2 based on message ID, inner join, and we also apply a filter Just so you know that you can also apply filter here. It's a streaming join. Actually, it's not a streaming join, sorry. It's not a streaming join, it's a materialized view here. As you can see, we used dot read, not dot read stream. Okay, so let's actually start our simulator here. So we can click run and it's going to start sending data. As you can see, it is sending data here. Message ID, device ID, temperature, humidity, wind speed, wind direction, RPM angle, and our IoT hub should start receiving data. It will take like a minute or two the first time, but in the meantime, actually, let's create our Delta Live table flow. Click on workflows, click on Delta Live tables, click on create pipeline, example Python DLT pipeline, right? Triggered, you can use triggered or continuous. Actually, we can use continuous here. Let's select the path, users, and DLT Python example. Storage location, Hive Metastore. Yeah, that's fine with us. Let's create target schema dot called example. Minimum workers 0, maximum workers 0. We don't need anything expensive. As you know, things can be quite pricey using Delta Live tables, so you have to be careful with that. Create and start. And in theory, if everything goes according to plan, it should set up the data and then start consuming data from IoT Hub and create our Delta Lake in Hive Metastore. It will take a bit of time to set up the tables and initialize the resources, but as you can see, it is running perfectly fine. We have the streaming tables here for the bronze layer. As you can see, we have already consumed 29 records for bronze turbine table and 31 records for weather table. And as you can see, silver table also has consumed here 80 records for turbine and 40 records for weather. And the materialized view on the gold table has been also created. The materialized view is going to automatically update, uh, you know, uh, once every few seconds, probably. Yep, as you can see now, it just updated. Now it has 18 records, and but as here you can see it's all those are streaming tables, and here the gold layer has a materialized view, but this is the recommended architecture by Databricks. Let's stop this Delta Live table pipeline. It's pretty cool, as you can see, right? And you can see details for every table, data quality. We have written almost 200 columns. There was no failures, so we didn't drop any records. That's the schema and the flows. We have all these for all the tables, right? So it's pretty cool if you think about it. We can also have, instead of a graph, we can use a list here. But let's see the actual tables. Click on catalog, and then in our new schema example for here, you can click on the tables and you can see the sample data. Let's see we can see data here, and we should have about 18 records on the gold table. Yep, perfect. And this is how you can use Delta Live tables to follow the Medallion architecture essentially in one notebook. You can create a whole Delta Lake in one notebook. Let's do the same thing using SQL instead of Python decorators. I have another script here, SQL script, that it creates Delta Live tables using SQL. The problem is using SQL, we cannot consume data straight from IoT Hub. At least I haven't found a way. I don't think there is yet. So the first step could be replaced using Python decorators. So we have already consumed the data using Python decorators. We have stored the data on the bronze tables, and here we create delta live tables using SQL and reading the data from the bronze tables. So create or refresh table bronze turbine SQL, for example, TS for SQL, and then we create a streaming table again from the bronze table into the silver table, and we apply the same constraints. We calculate the average again, and we based on message ID, we group by message ID, and this is the window function. We group by timestamp for every 5 seconds. This is a streaming delta live table. Also for the silver weather table as well, we have streaming live table. We perform the same constraints that we performed using Python, the same aggregations and filtering here. As you can see, wind direction equals left, and the window function every 5 minutes using the time 5 seconds using the timestamp column. And then we create a materialized view. So a delta live table is essentially a materialized view, and we also have the delta streaming live table, which is a streaming table, right? So a simple delta live table is actually a materialized view, and here we select and perform an inner join with a where clause. It's exactly the same thing. So let's create another delta live table pipeline. Create pipeline, DLT SQL example, triggered this time, so we don't need continuous. So yep, select your script, Hive metastore example, minimum workers 0, 0. Okay, this is perfect. Create. Before I run it, I have to actually delete the previous pipeline, because otherwise I will reach the quotas. So let me delete the other pipeline first, and then run this delta live table SQL pipeline. Our delta live table SQL pipeline is up and running, and as you can see, we have already written the data to the gold layer. You can also refresh the data. So you can see, you can click on a table, then select tables for refresh. You will see the graph again, and then select a table, click refresh selection, and start the pipeline again to refresh the data. But let's actually see in the catalog, let's see the tables that we used, that we created using the SQL Delta Live pipeline. So as you can see, we have the gold. This is the gold table that we created using Python decorators, and this is a gold table that we used using SQL. It's a little bit different because I have added I have selected different columns. But essentially, this is the case. This is how you create Delta Live tables, pipelines, and this is how you can create a whole Delta Lake using the Medallion architecture, essentially in one notebook. How cool is that, right? This is it for today, guys. I hope you enjoyed the video and you learned something new. I'm going to upload the notebooks on my GitHub if you want to take a look, and if you want to play around with the same example, because I think it's a pretty clear and nifty example and pretty simple at the same time. From the next video onwards, we are going to continue with our Databricks tutorials. So until then, thank you for watching and see you in the next one.